Okay, we have a pretty full crowd here at the moment, so good morning, afternoon, or evening, depending on where you are located. I have the honor and the pleasure of introducing Dr. Laurent Bernardin. Laurent received his PhD at ETH Zurich in Switzerland after studying with Gaston Gonnet, one of Maplesoft's co-founders. Laurent has had a long history with Maplesoft, first working on Maple as a student and then taking on a number of different roles at the company before eventually taking the helm as president and CEO in 2019. He knows the products inside out, having taken part in many facets of their development. And on a personal note, Laurent was manager of the math group when I applied to Maplesoft 21 years ago. At my interview, his enthusiasm for Maple and the company convinced me to join. His belief and passion for our work is really still as strong as ever. And I'm sure you will get a sense of that in his presentation. So I'll pass it over to you now, Laurent.
Thank you very much, Paulina, for the kind introduction. Hello, everybody, and thanks again for joining us today. It's people from all over the world, so whether it's good morning, good afternoon, or good evening, I'm really glad that you're here with us today. Well, we'll talk about math in changing times. Just bring up the slides. And you know, contrary to our collective recent experience, not all changes are bad. And we'll talk about things that have changed recently over the last year, months, and how they impact maths, how they impact teaching maths, and in turn, how they impact how we see things at Maplesoft. But first, I'd like to talk about some things that have not changed, that some things remain constant and probably will remain constant for a very long time. First thing, math still matters, right? Math matters, math is ubiquitous. If you look around our daily lives, you find math everywhere, and it's important. And we saw that at the keynote yesterday again, right? Stressing that wherever we look, math underlies our daily lives. And the other thing that is still true is that everybody can be a mathematician. Math doesn't have to be scary. Math doesn't have to be, I don't have to be a math person to enjoy and appreciate mathematics. And I would go one step further here, and I would say that everybody must be a mathematician today. Not in the sense, not a mathematician in the sense that's your career, or you're a math professor, or you do this as for a living, but in the sense that everybody must have an appreciation of mathematics. We are constantly bombarded with math. Right? We've seen recently, of course, lots of statistics, lots of numbers, lots of data, and really it's important that everybody can appreciate what's behind those numbers and what they mean. You go out, buy a house, get a mortgage, you deal with interest rates again, right? So there's math there. There's math everywhere around us, and it's crucial that we understand and appreciate. So therefore, not just everybody can be a mathematician, but everybody must be a mathematician. The third thing that remains constant is that the teachers and instructors still make the difference. Math matters. Math is important. Math is everywhere. Everybody needs to become proficient at this. It can be scary. It can be hard. Right? Teachers make the difference to bringing mathematics closer to students everywhere. And of course, our mission at Maplesoft is to make that job easier, to provide tools that make learning math, teaching math easier, more enjoyable, more effective. So some things remain constant, but things have also changed. So let's talk about that next. So of course, the most obvious one perhaps is asynchronous learning has really taken off out of necessity over the last couple of years. At the same time, AI, machine learning, artificial intelligence, we've really seen an emergence and a maturing of that technology. And it's been entering more and more aspects of our lives, but also in particular teaching. Access to technology, again, as a necessity, I think access to technology has been taken to a next level over the past few months. More people than ever have access, have the tools because they need the tools. And at the same time, also we have seen that that familiarity with technology has risen considerably. Many teachers that before the pandemic maybe were very much in a traditional teaching mode on the whiteboard without using much technology, were driven to adopt these technologies. Again, mostly sometimes because they have to. But the consequence is that now, not just the students, but also the instructors are very familiar with technology and very eager to use them. Another thing that has changed around the world is the awareness of issues around diversity, equity, inclusion, and that plays a really important role when we talk about how our environment has changed and how teaching of math has to adapt. Now, these things have changed, but there's also some consequences to these changes, and one of these consequences is that getting student engaged has been a challenge. And I should say here that asynchronous learning and remote learning and teaching over Zoom, right? The experience is different for different people, different for different instructors, different for different students. But so I'll generalize a bit, but generally I think students have a hard time. It's much harder to get the students engaged and keep the students engaged if we don't have them in the classroom where we have direct access. And the consequence of that has that we've seen a lot of teacher burnout. It's just tough. It's tougher to teach than ever, and the big reason is, right, that to get that student engagement is just a lot harder. So we've come up with new ways of teaching, new ways of making the content come alive, and new ways of getting that engagement, and new ways of making it exciting. But we also seen that there's new ways of cheating, and because with remote learning, with asynchronous learning, there's so many resources out there that somebody can go to get answers, and of course, right, it's it's easier than ever to cheat. So that also has to feed back in the way that that math education works. And one consequence is that we just have to assume that yes, the students, right, they can go out and they can get the answers, they can get worked solutions, and it's very easy to find that mobile phone or on the internet, right? It's very easy. So that means that we have to adapt the ways that we teach the subjects. Access to tools has risen. I said access to technology has increased, but also access to tools. And whereas before students came into the classroom, past few months many had to do their learning remotely, which means that they have access to a laptop, to an iPad, to a Chromebook, to something that allows them to access those tools. And the social inequalities, something that hasn't changed, but has been made worse by recent events, because access to tools, access to remote tools, access to internet, it's more important than ever, and for some that is a real challenge. So lots of things have changed, and lots of consequences of this change that we are forced to deal with. We have to recognize, and we have to react, and we have to come up with ways to adapt and to make this better. Another thing another consequence is that perception of online learning. So and this is a double-edged sword, whereas awareness of online learning has risen. More and more people than ever have been exposed to online learning, but it hasn't been across the board a positive experience. So in some sense, this has left a bad taste in many people's mouths. Right? A bad taste of online learning it's not working as well as it should. Of the sense that no, online learning maybe doesn't work, right? Would much rather be in the classroom. And I think that maybe has made us take a bit of a step back, and is a negative for the concept of online learning, because we were thrown into this really not very well prepared. But personally, I think that online learning can work better than it currently does. But we need the right methods, and we need the right tools. And again, that's what we're here for, right? That's what Maplesoft we're thinking about every day. What can we do to help? What do these tools need to be? What are ways that we can help? So what if we could multiply student engagement? Even in an online environment, even in a remote setting, what if we could truly engage the students? What if we could convey that love of mathematics, that appreciation, those insights, even remotely, even whether it's asynchronous or synchronous? And let me just pause here and give you an example of what I mean with that. So of course, with Maple, right? We've long worked on making Maple easy to use, easy to access, easy to get started with. And in particular, the concept of the math apps, where in Maple you'll find hundreds of interactive examples that pick a particular topic in mathematics and make it come alive. It's hundreds of these examples, and the collection is growing with every release. Right? And it's been something that also from the feedback that we have received from you is really working. You learn mathematics by doing mathematics, and the math apps allow a student to touch concepts, to play with them, to interact with them, and that does make a difference in engagement. And so we decided to take this a step further, and oh no, by now I think that recently we launched Maple Learn as a new product. Maple Learn is an online environment that is based on the Maple mathematical engine, but the UI is in a browser, and it's designed to be very accessible and very easy to get started with. So here's an example of what a document in Maple Learn could look like. This particular one looks at a proof for the derivative of cosine, and it has all the mathematics, but it also has a visualization that makes this come alive. So this one here shows the slope, right? And as I move the point, I can kind of see what happens. So if I'm at 0, the slope is 0. Right? If I'm on top here at 1, the slope is 1. So you can kind of play with these. Very similar to the math apps in Maple, but maybe with two key differences. One is that it's online in a browser, and that's very easy to share these documents with anybody. And the second difference maybe is that these are even easier to create than they are to create in Maple. And I'll give you an example. I'll show you that just by building a quick one. Right? Let's maybe enter a couple of points. X1 equals 1, Y1 equals 1, and I'll create a point of the sphere. X1, Y. And that makes the point show up there. Right? So that was all it took to get a point on my plot. Let's do another one. X2 is 2, Y2 is 3, and we'll call that B. Now we have 2 points. To get let's make a vector between those two. Let's just do a vector of AB. I now have a vector between those 2 points. So I'll do a third point. That, and then I'll put another vector between B and C. I'll put a vector from A to C. And so I very little, right? Very easy I built a plot that contains 3 points, 3 vectors. But now that's all it took to make this interactive, because now I can take these points and I can move them. So in what, 2 minutes, I build an interactive application in Maple that allows you to visualize vector addition. So very, very easy to do. And as I said before, also really easy to share. So I'll do now is I click the share button. It says put a link on my clipboard. And I'll actually put this into the chat. And I'll send this to all of you. So now you can go to the chat, and you can click on this, and Maple will come up with this particular document, and you can start playing with it. Right, so we see that as the next step in regaining student engagement. Interactive math apps, interactive applications that illustrate concepts in mathematics that you can touch, that you can play with and interact with, but now even easier to do and even easier to access than ever before. Back to the slides. So student engagement, and what if we could scale teaching excellence? And that's really one of the promises of online learning. If as an instructor you have figured out what is the best way to teach a particular objective, you really dug into that, and given your experience, you figured out, okay, if I take this subject or this particular concept, I figured out the best way to teach this. Well, how can we scale that? How can we make sure that everybody can benefit from your experience? Everybody can benefit from being taught in that way that arguably, right, this I think is the best way to do it. And maybe not just an opinion, but maybe that right is proven by data that, yeah, this is the right way to teach this concept. So then what do we do with it? How can we scale that? How can we provide everybody with access to the best ways to teach and learn any concept in math? And again, I don't have full answers here, but I will give you an example of what that could look like. And just go out of here for a second. So back to Maple, and make sure this works. So I'll do something very, very simple. I'll enter a fraction. 1234 divided by 54. And okay, I want to do long division. So in the context panel in Maple, you find long division. You can click that, and I get the answer. Okay. teaching long division is actually not easy, because there's lots of different cases to consider, a lot of things that can happen as you go through the process. And also, just looking at the answer, it's not clear at all how you get there. So here's an example of one way to address that, and I'll show it to you first. So I'll click the Live Steps button here.
Let's divide 1234 by 53 using long division. 53 is the divisor, and the 1234 is called the dividend. First we check how many digits of the start of the dividend we need. Does 53 fit into 1?
I'll just pause here for a second and say that what you're seeing here is not a video. It's Maple on the fly, given this particular problem of 1234 divided by 53. Maple on the fly producing a step-by-step solution for this. And not just as a step-by-step, but it also emulates somebody on the whiteboard going through the solution, including the narration of it. So everything is generated on the fly based on the particular problem that we entered. So I'll keep playing this for a bit.
No, it does not, so we need to grab one more digit of the dividend. Now, does 53 fit into 12? Well, it still doesn't fit, so let's use another digit of the dividend. Does 53 fit into 123? Yes, 53 is less than 123, so we have enough digits to start. The next step is to figure out how many times 53 fits into 123. Well, 2 times 53 is 106, which is less than 123. However, 3 times 53 is 159, which is too big. So, 53 fits into 123 twice. That gives us the first digit of our quotient. Now we have to multiply that digit by the divisor. 2 times 53 is 106. We write that result, 106, under the current part of the dividend with a minus sign. Now we subtract. 123 minus 106 is 17. We now have to find the next digit of our dividend. Let's pull that digit down.
Okay, I'll spare us the rest, but you get the idea. And I think there's something very powerful. It's being able to take a problem, creating a worked solution, and based on the particular problem that was entered, and to make that solution come alive. Right? Not just a static set of steps, but actually mimicking somebody going through solving it, which gives you a lot more insight into what is actually going on. And it turns out that Maple is a great platform for building these sorts of solutions. Because of course the most important ingredient here is the teaching experience, the knowledge as to, okay, how do we teach long division, and what can go wrong, and what errors is the student likely to make? What can we right? How can we convey this in a way that it's useful and achieves the objective? Building something like this is work. Even in Maple it's still work, but you do it once, right? And then it scales, and you can reuse it hundreds of thousands of times. And it scales in the sense that now students around the world can benefit from the way you are teaching a particular concept. And related to this, right? Also on MapleLearn, there's a lot of there's a gallery of pre-created documents with hundreds and hundreds of documents that are there now that are built using MapleLearn, that look at a particular topic, make it come alive. Some have worked solutions. Some allow you to practice a concept. Some give you feedback as you do that. Right? Hundreds of these documents, but of course the idea, the real win, right, is for us to build a community, hopefully with your help, to where we use MapleLearn as a platform for instructors around the world to build content like this that can then be scaled worldwide. Okay, let me go back to my slides here for a minute. So we talked about student engagement, we talked about scaling teaching excellence. So what if we could leverage this technology to really reinvent math education, right? A bold statement, and again, I'll only give you an example today of what that could look like. And it's really taking everything that we just talked about and putting it together. So let me go again into MapleLearn to make this point. Okay, here's not a MapleLearn document. We have a linear equation. Not the one I wanted. Hold on. Let me pull out a different one first. Let's start with this. So linear equation in MapleLearn. Okay, so let's don't need to plot for this. Let's go through and solve this by hand. So we're gonna say 2x minus 4x. That is minus 7. It's 3. So then that's minus 2x is minus 4x 2. It's 4 over minus 2. And we can say x is 2. All right. Now let's check this. So so now what happened is something went through my worked solution here. And look at every step. And tells me to check this because I probably made a mistake. But it also tells me that okay, there might be a mistake here, but going from here to here, that was done correctly, and from here to here is also correct. And if this was correct, then the final answer would be okay too. Right? But there is a mistake here. Right? So now I can go back and I can fix that. I can so So it was really minus 3, right? Which means that this is a minus 10. So 10. And then this must be a 5. Let's check it again. And this time, yeah, it found the correct solution. And you know, the best thing about this is that what's going on behind the scenes here, what is checking the math, what is deciding where a mistake was made, and also what's deciding whether the next step is correct if we assume that the previous step was okay. That's all done by a Maple program. So something that we're all very familiar with. So everybody who is able to write a Maple program can write their own solution like this, their own Learn document that takes a particular type of problem, allows the student to go through, produce a worked solution, and then the Maple code will check and will provide useful feedback. And it will not be just, okay, the final answer is correct or the final answer is not correct. Right? It will be deeper feedback that points out errors, points out possible problems, and guides the students to really learn something out of it. And okay, so to do this, I had to the student, right, got the problem, had to enter the steps in Learn one line at a time, right, to get that feedback. And that's sometimes an obstacle. So, but the good news here is that we can take this one step further. And let me show you the Maple Calculator mobile app. Let's see. All right. So that is what the Maple Calculator looks like. You'll find it in the Google Play Store or the App Store. You can enter a piece of mathematics, and you get the same sort of functionality that you get from Maple, because again, here in the background there's a Maple engine that gives you answers. Solve for X. Fact. Gives you the step-by-step solutions if you want. But you can also take a picture of handwritten mathematics, and let me just do this on the fly. Let's see if I can make this work. So my handwriting is pretty terrible, but let's see if I can make this work. Also kind of not in focus. Okay, let's try it again. Maybe that was too bad. I actually forgot the dx, so maybe that's part of it. Almost got it right. Of course, this is a demo, so not everything will work. But I can go back and fix this. Right? I get the answer. I get the step-by-step solution. But going back to my example from before, where I was solving this linear equation by hand, I can also do this on the phone. So I can actually solve that same equation, pen and paper, then take a picture of it with the calculator. And this will, stop sharing here. This will actually now transfer this the whole steps of what I wrote down on pen and paper, and I can access this in Maple Learn. So I'll go back to Learn. I'll find whatever I didn't calculate. I'll find in my palette here. So I can go and I can say, okay, I want this thing in my Learn document. So as opposed to having typed all this in, right, I could just have grabbed it from the picture I took on the phone, right, and then same thing. I can go through and verify what I did. So very, very powerful and very easy to use. And let's go back. I told you before that that this is under the hood, all driven by Maple. And that what you see doing the work here is Maple's math engine, but also that you can that there's Maple procedures, Maple programs in the background here that will check answers and provide feedback. And let's just go to Maple and see what that looks like. So here, first off, right, you don't have to get into programming to do this. So there's a bunch of pre-built commands, like the solve practice command, which I can give any example. And Maple will generate me a link, a Maple Learn link for this particular example that I can click on. And now I can go and again, step by step, solve this and get feedback. So that's as easy as it is. Here's an example of what some of the code could look like. This is taking it another step further, actually. So if I click on this link, it gives me an example. I can solve it. I can say, okay, 2x is 1. And check. Yeah, that's correct. This time I actually got it right. Right? But you can also here again use Maple to ask for another problem of the same type. And this used to work. Does not work right now, but this is a demo. But what should happen is that whenever I press that button, the try another Maple procedure is getting executed, which creates a new similar problem, and will populate the document with this new problem. So that allows now a student to go practice something, get feedback where they went wrong, fix it, get to the solution, and then obviously they need more practice because they made some mistakes, so they can try another. You can try another example of a similar type, of a similar level of difficulty, and there's an endless supply because again we're using Maple in the background to generate this. All right. Second. So those are some examples of what I mean with multiplying student engagement, what I mean with scaling teaching excellence, and ultimately what I mean with how can we leverage technology to reinvent how we teach math. So math education everywhere for everybody. I showed you the Maple calculator. It's a great way to get started. It has the full power of Maple's engine in the background, but it's very accessible. Right? Everybody has a mobile phone. You download the app. You get started. You take a picture of math that you want to solve. There's an editor that you can enter your own expressions. So you get graphs live. So very easy to get into, and it allows you to also then take a picture of a work solution that you did with pen and paper, and then get that right into Maple Learn, into our online environment, where you can access these things using a browser, build interactive documents, explore stuff, again with graphs and sliders and interactive elements, and again without putting any hurdles in front of you. You go to learn.maplesoft.com. You get started. It's free to get started. There's a premium tier if you want access to the entirety of the power, but it's free to get started. And then of course Maple and also new Maple Flow, and you'll hear more about Maple Flow elsewhere in the program. Maple Flow and Maple on the desktop, where you really have access to everything that is possible in the Maple world, and you have this strong connection now back to online, to Maple Learn, and the interaction of being able to produce content right from Maple using the familiar Maple programming language, and then using that to build highly interactive and highly engaging experiences online in Maple Learn. Thank you very much. I'd be happy at this point to take any questions.
Okay, thank you very much, Laurent. We really enjoyed that talk that generated a lot of interesting discussion and ideas. In the chat, there were a number of comments about people very impressed by the live demos, that they all worked flawlessly. I have to say that at our company in the past, some of us have teased Laurent about his messy handwriting, so I find it even more impressive that all that worked really well. So there are some questions in the chat. Some of them you've already answered partially, but I'll read them out in case you want to say more. So one question, you had been talking about student engagement. Are there any objective measures for student engagement?
I'm not aware of anything official, right? I mean, it's tough. I definitely was watching my own kids all through the pandemic, and again they each had 3 kids. They each had a different experience, but some struggled more in staying engaged and being engaged with their studies while they were not in the classroom. Right? And how do you measure that objectively? I don't know. Right? But it's a problem. The problem is real. And there's things that we can do to make it better.
Great. There was a question about one of your calculations earlier, and said, can we do this calculation by hand and check using Maple Learn? And I think you showed an example with the phone and so on. But did you want to say anything more about that?
Yeah, I mean, the nice thing about Maple Learn is that it's you're able to automate it. You're able to use Maple to produce a Maple document that is live and that where things happen, right? So for example, that's when we press the track your work button, right? At that point, there's a Maple program running that has access to everything that the student typed. And that program, that Maple program, can now decide what changes to make in the Maple Learn document. And it can annotate it, it can add text, it can change things, but it can really do anything to that document that the user of Maple Learn could do using a mouse. Right? It could move things around, you could color things. Right? So yeah, it's a very rich environment for producing experiences where based on a Maple calculation, we make changes to an online document that conveys the results to the student or to the user, and that makes that thing come alive.
Okay, thank you. Then there was a question about, can you talk a little bit about the kinds of equations that can be handled in Maple Learn? Systems of more than one equation, nonlinear equations, what's the scope?
Yeah, I mean, ultimately the goal is to make it do everything that Maple can do. But the first primary focus maybe is on the lower levels of mathematics. We focused it on upper high school and first second year university. So that's what the goal is, and that's what the scope is that you can do in Learn. You can do linear equation, nonlinear equations. You can do differential equations, matrix, linear algebra, right? Statistics. It's the scope is pretty big. And also Maple Learn is still a young product, right? So that's what Learn can do will continue to grow.
Okay, I love this next question. What is the secret of efficiency of Maple 3D graphing? Something that takes eternity, or well, 3 minutes, in other platforms takes only a second in Maple. What's the secret?
Yeah, I can't tell. It's a secret.
Right.
But we have a lot of very smart engineers and developers in our team.
Okay, here's a good question. I understand how to build single Maple Learn apps, which is great, but how to bind them together in a kind of book or for a whole course? Can I implement it in Mobius or even Moodle?
So that is yes, because as I showed you, you can turn any Maple Learn document into a link, and those links you can collect those wherever you want to collect them, right? And if you have a piece of Mobius content, you can add a collection of Maple Learn links to that. So your book becomes a web page of links to Learn documents.
Okay, the long division video was great. How long will it take to create a polynomial long division demo?
Yeah, so these things are not easy to create. So they are work, right? And in particular, they are work because if you actually try to sit down and do something like this, you find a lot of corner cases. You find that teaching something like long division is actually pretty hard if you need to cover all the possible things that can arise. Right? So it is work to produce these, but the platform, the Learn platform, really supports these. And while it's work and takes some time, once it's done. Because likely the way we teach long division is not going to change very much over the next 50 years. So once it's done, and then you reuse it as many times as you want, and so that investment pays off.
Okay, there is one final question, but I don't know if we have time to cover it because it is a question about drawing a graph specifically of a function in the calculator and what sorts of difficulties. So I would ask the author maybe pop into the networking session later today, because some of us will be there and we can actually, try it out and do it then. So as we're just about out of time, I'm going to say thank you very much, Laurent, for that very thought-provoking talk. Thank you all for joining us and engaging in the conversation. Thank you again, and goodbye, everyone.
Bye-bye. Thank you.